Welcome to this video about significance tests for a difference in proportions. By the end of this video, you should be able to calculate the standardized test statistic and the p-value for a test about a difference between two proportions and perform a significance test about the difference between two proportions. All right, so we're going to walk through this. And we're going to do this the way our formula sheet originally says us to do this, but today's kind of one of these days where we're going to learn something, and it only works for this kind of scenario of a significance test for difference of proportions. All right, so we're revisiting the problem scenario that we talked about last unit. We did a confidence interval about the difference between the two proportions previously. Now we're going to do a significance test. So we have 50 juniors, 28 said they're planning on attending prom, and they have 45 seniors and 29 of them are planning on attending prom. Do the data provide convincing evidence that a higher proportion of seniors are going to go to prom than juniors? Use a 5% significance level. So that's our alpha. So let's go through all the things that should be in state. So for state, you got to define your parameter. So we're going to say our parameter of P1 minus P2 is going to represent the true difference of proportion of grades going to the prom. And I'm going to have us subtract, it doesn't say in the problem, we're going to do junior minus senior, okay? If the problem doesn't say, you can pick, but you always have to state what you're doing, what direction the subtraction is. Even if they tell you, you're going to want to mention it in here. So what we do by writing it like this, and we're automatically defining P1 is juniors and P2 is seniors. Okay, so it's like an implied definition that you don't have to say, you don't have to further define. We can do this kind of a lot quicker this way and save yourself a room and give you more time to do the actual work. So our hypotheses. Let's hold off on this until we get our statistics. Let's pull them out of our scenario here. So remember, we're going to talk about the P1, that means juniors, because we said junior minus senior, and the order is P1 minus P2. And this is a statistic, so it's going to have a hat on it. For the juniors, there were 28 out of the 50 who said they would be planning to go to prom, for a proportion of 0.56. And for our seniors, there were 29 out of the 45 who said they were planning to go to prom, for a proportion of 0.64. Okay, so those are our p hats for juniors and seniors, and we want to know the difference. So we're going to take p hat 1 minus p hat 2, which is 0.56 minus 0.64, which gives us a difference of negative 0.08. Okay. The problem did tell us to use the 5% significance level, so alpha equals 0.05. Now, we're going to write our hypotheses. Remember, this is there significant evidence that a higher proportion of seniors are going to prom? Okay, so when we write our null, remember null means no difference. So we're saying here, if we take P1 minus P2, there'll be no difference between them. What that means in words to kind of help you with this is juniors and seniors are the same. So proportionally, they're going to be the same proportion of juniors and seniors going to prom. The alternative is, we want to know if there are more seniors going to prom. If we're doing juniors minus seniors, and we think there's more seniors, that's going to give us a negative result when we subtract. So our alternative says juniors minus seniors will be less than 0, because you'd end up with a negative result if there were more seniors. So in words, that just means more seniors. All right. So that's what we've got so far. Hopefully that makes a lot of sense. So remember, when you do this for a test or on the AP exam, the 4-step process, you're not going to have these hints. You have to remember all of the things that go into the state portion. Okay, our procedure, we had 2 different samples. So this is a 2 sample. We're going to be using a Z-score later, and it's a significance test. So we say test for, and then we're looking for a difference in proportions. Now, we got to check our conditions as always. So we have our random, and we did have random samples for both groups of 50 juniors and 45 seniors. And that means we can generalize to the population because we had a random sample. If this was an experiment, we'd be looking for random assignment. 10% has to be checked because this is sampling. If this was an experiment, we would not have to. So 50 is less than 1/10 of all the juniors. And 45 is less than 1/10 of all the seniors. Okay, and our last one is our large counts. Okay, so we have 50 seniors, and their proportion was 0.56. So this is going to be 0.44. So I had 28 and 22. And both of those are greater than or equal to 10. And then for our seniors, there were 45 of them. And their proportion was 0.64, which makes this one 0.36. So I got 29 and 16 for the for the seniors, and both of those are greater than or equal to 10. So our sampling distribution would be approximately normal. Okay, hopefully you're like, I got this. Here's where we get a little more into it with the formulas. So hopefully you have your formula sheet handy for you, so that will be helpful. So the mean, remember, we're always assuming the null is going to be true. If the null is true, our sampling distribution should center around this value of 0. So for that reason, the mean of our sampling distribution should be the same number. So in this case, 0. And it's always going to be 0 in the AP Stats world. To find our standard deviation of our sampling distribution for the difference of these 2 proportions. Okay, so this is on our formula sheet. If we look at the back of that first page of the formula sheet, you got to look under proportions because we're doing proportions, and we're talking about the difference of the proportions. There was where we had the mean of the sampling distribution is the same as the parameter, which is what our null is. Then here is our standard deviation formula that we had been using previously. Remember, you're adding the variances even though we're looking for a difference in proportions. So we're going to plug in our values. So we have the juniors' proportion times their failure divided by their sample size plus the seniors' proportion times their failure divided by their sample size. And when I calculated that all the way out, I got 0.10. Okay, our picture, always draw your picture and label it. Okay, so if this is our sampling distribution, we assume the null to be true, so it should center around 0. We got negative 0.8 from our sample, so that's over here somewhere, and so we want to know about there or more extreme. So we're talking about all this area over here. We want to tell our readers that this is a normal curve with a mean of 0 and a standard deviation of 10. So we've got everything included there. The general formula is the words. So this is your test statistic, which is the z-score. Takes the statistic minus the parameter, divide by the standard deviation. Okay, because that's all your formula sheet says. It says it in words. It doesn't give you the specifics. So for us, the specific formula, what it's going to look like, where all the numbers come from, to get your z-score. To get your statistic, you take whatever p-hat1 minus p-hat2 is, and you're going to subtract p1 minus p2 from that, and it gets divided by this big old standard deviation formula of p-hat1 times 1 minus p-hat1 divided by n1 plus p-hat2 times 1 minus p-hat2 divided by the second sample size. Okay, so that's our formula that we are going to plug all our numbers into, because it's going to look a whole lot shorter once we plug in our numbers. So to find the answer, to find our z-score, well, p-hat1 minus p-hat2 was at negative 0.08. Our p1 minus p2, if we're assuming the null to be true, so that's 0. And the standard deviation we just calculated right here of 0.10. And when I did that, I got a z-score of negative 0.80. You should try this in your calculator to make sure you're getting these same numbers. When I look up on my table of values, negative 0.8, I got a p-value of 0.2119. Okay, so I don't want to make a conclusion right now, because here's where things are going to get a little weird, because there's a special scenario that comes up only when doing significance tests for difference of proportions. Okay, so if you have a different color, this is the time you definitely want to do this. This is very important, that what we're about to talk about. So back up here, doing our formula for our standard deviation, we need to do some changes here. So we're going to do something called pooling. Okay, and pooling only happens for significant tests for a difference of proportion. It's the only time this is going to happen. Okay, so this group up here, when we're talking about these guys, they're coming from the same population. We got their numbers, these probabilities, from a conditional proportion. We said out of the juniors, we got this. Of the seniors, we got this. But we want to talk about them as a whole group. So what we want to do is we want to make them an overall proportion of the total group. Okay? And so what that looks like, here's the symbology for it. So to find the pooled p-hat, that's what that is. You're going to take the value of the first one, like the number of people going to prom of juniors plus the number of people going to prom of seniors, add those together, and you're going to divide them by their sample sizes. So for this case, it looks like there were 28 juniors going and 29 seniors. There were 50 juniors plus 45 seniors, which gives us a pooled proportion of 0.6. So 60% of all of the people who were going, who were surveyed are going to prom is really what this is saying. That's the number that we want to use. Okay, so we don't want to use the individual p-hats. We need to have them to calculate our statistics here. But anytime we're doing a significance test for a difference of proportions, for everything past this spot, we want to use this pooled value. So this is what I'm saying. You want to use the 0.6, and so that would be 0.4 right there. We don't want to use the individuals, we want them all together. So 0.6 and 0.4. So what happens is it's going to change our numbers, and you're going to see it's not going to change them a lot. We got 28 here. When I recalculated it, I got 30. It's not a big change. We had 22. When I recalculated, I got 20. Okay. 45 times 0.6 is 27. And 45 times 0.4 is 18. We're still approximately normal, but we want, for our large counts, we want to use the pooled proportion. Okay. Same is going to be true for our standard deviation. Okay, so we don't want to use these individuals. We're just going to say this is 0.6, that makes this 0.4. This is going to be 0.6, this is going to be 0.4. This part stays the same, but we're saying they're all part of the same group. Okay. What it does to our standard deviation, instead of 0.10, it makes it, wait for it, 0.101. It's not a big change, I agree. I mean, it may seem trivial, but it's important to consider them as part of the whole instead of two separate groups. Okay, so what our formula is going to look like, it's, I'm going to show you the easiest way to use it. Our formula shows it just a little bit different, but I'm going to set it up just like this one because it's a little easier. You're going to have the pooled proportion times 1 minus the pooled proportion divided by that sample size, plus you're going to use these same numbers again. The pooled proportion times 1 minus the pooled proportion divided by the second sample size. Okay, it's a little different than how it's written on our formula sheet, but it's kind of easy to remember and use if you remember to pool. Okay, so when I have my z-score, instead of dividing by 0.10, I'm really dividing by 0.101, which gave me a z-score of negative 0.79. And of course, because my z-score changed, my p-value changed to 0.2148. So you're just trying to work with these two groups as part of the same whole instead of two individual wholes. Okay, that's the purpose of pooling. And so you just have to remember that this is an exception that is only in this case for difference of proportions for a significance test. All right, so let's look at the conclusion here. So what I want you to do is pause the video, and I want you to write the conclusion and then come back and compare it and see how you did. Remember, there's 3 major components. You want to assume the null is true, and what does that mean about the probability of getting the difference that we got? How does the p-value compare to the alpha value? And what is your decision about the null? Okay, so pause the video, give it a try, and come on back and see how you did. All right, let's see how you did. So assuming the null is true, so I just went ahead and wrote in the null. You can write assuming the null is true and put that in parentheses, as long as you're getting the idea in there, and you need to include what the null is. So assuming p1 minus p2 equals 0 is true, there's a 0.2148 probability of getting our result, which was p hat 1 minus p hat 2 equals negative 0.08. Make sure you've got this in there. Or less, because we had or less in our shading, purely by chance. Because 0.2148 is greater than our alpha 0.05, we do not have convincing evidence of a higher proportion of seniors going to the prom. Because we do not have evidence, convincing evidence for our alternative, we're going to keep our null, so that means fail to reject the null. All right, so let's do some summary on the back. All right, so please remember, pooling is only used for significance tests for a difference of proportions, okay? the only time. It's kind of an exception. It didn't look like a big difference, and pretty much every time you're going to do it, it doesn't look like it makes a big difference, but we do need to still do this. So as part of our summary, I want to make sure we're kind of covering the do part of our 4-step process here. Make sure you draw your curve, that you label it. So we've got with our mean and our standard deviations. Okay. And you'll have your mean listed here, which is going to be 0. It can be something other than 0, but in the AP Stats world, we're only going to do where it equals 0. Okay, to find your standard deviation of your sampling distribution, or the difference of the proportions. Remember, this is the new formula. You want to use your pooled numbers. So they're out of the same whole instead of 2 different conditional probabilities. Okay. To find your pool, remember you're going to take the successes of each one and add them together, and then add together the sample sizes. Okay. And that will give you your overall proportion. Remember, that means pool. Okay. And then your Z formula looks terrifying, but just to remind you where the number's from. Your statistic comes from p hat 1 minus p hat 2. Your parameter comes from your null. And then your standard deviation is this big long one of the pool, using the pooled divided by their sample sizes. And remember, you're always adding them together because they're the variances. All right. Now, the other part for our summary here is the conclusion. All right, so let's get that. Okay, so our concludes are pretty long, but it has the 3 parts in it. So the assuming the null is true, there is a whatever your p-value probability of getting our difference in proportions, so please make sure you put that equaling what we get, or less or more depending on which way you shaded, purely by chance. Because your p-value, how does your p-value compare to alpha? We either reject or fail to reject, that's FTR, fail to reject the null, and do or do not have convincing evidence for the alternative in context. So I've been taking this, the reject and the fail to reject, I've been putting it at the end a lot. You can put it in the middle. This is how your book shows it. That's perfectly fine. I've been putting it at the end. It doesn't matter where you have it as long as you have it. Okay, so what I want you to do is check your understanding all on your own. See how you do. Come back and check the key. Let me know if you have any questions. See you in class.